Great. So welcome back to Grade 8 Math. We're now starting a new chapter on transformations. And so this is a little bit of geometry and spatial sense. Let's just review what the four transformations are. We learned these in grade 7. The first one we'll be looking at is called the translation. This is the fancy word for slide. Then we also have the reflection, and that's the fancy word for flip. Then we have rotation, which is the fancy word for turn. And then the last one we have is the dilatation, or the dilation. And that's the fancy word for grow or stretch. And so let's look first at translations, because that's part of these first three. These first three, what they basically do is you're just moving the shape. So which means that the shape is exactly the same as the original shape. So we have congruence in these ones. That means the original shape, congruence, which means the original shape is exactly the same in terms of the angles, in terms of the side lengths, and the number of vertices. All of that stays the same. In a dilatation, this one's slightly different because this creates a similar shape because you're changing the size, which means the angles would stay the same, but the side lengths would change. So that's why those shapes are not exactly the same. So they're kind of two families of transformations here. So we're looking at the first family, which is the congruence ones, and we'll look at translations first, which is the slide. The notation for a slide, sometimes you'll see a letter T for translation, and then you'll see square brackets. Sometimes you might not see the letter T, or sometimes you'll see the letter T and round brackets. But in the textbook, but also for our conventions, square brackets would also mean the translation. And so translation means slide. The first number in our coordinates that you would find in your translation vector. Translation vector means an arrow that shows the movement of something. The first number tells me how far am I moving in the x direction. So which means if I'm moving 3 spaces to the left or 2 to the right or whatever it is, it's left or right. The second one tells me the y direction. So that's why I use the letters A and B, because it's not exactly x and y. So this one tells me the up and down. So an example is if I see translation of 3, negative 2, or square brackets 3, negative 2, both of these mean the same thing. This means 3 to the right, because right is positive, and 2 down, because down is negative. So if you just wanted to remind ourselves of our directions, right is positive, left is negative, up is positive, down is negative, just like in our Cartesian plane. So this is our translation vector. So rather than using the words 3 right and 2 down, we just use square brackets 3, negative 2. And so that tells us that point is moved. So here we are starting at point A, negative 2, negative 2, which is translated to the image A prime, negative 1, 3. Describe the translation vector using AB and also using words. So let's plot these two out. So negative 2 is here, and we'll mark this A. And then negative 1, 3 is up here. So this is A prime. And so I want to be able to describe this translation in words. So the vector is, if I look in the x direction first, it moves 1 positively in the x direction, and then it moves up 1, 2, 3, 4, 5. It moves up 1, 5, or sorry, it moves 1, 5. In words, so this is the grade 7, I would say 1 block to the right, and 5 units or 5 blocks up. So now let's answer these couple of other questions just as a review from last year. In which quadrant or axis can the object and image be found? So the quadrant of the object, if you remember the numbers of the quadrants, this is 1, 2, 3, and 4. So object is found in quadrant 1. Sometimes you'll see the Roman numeral 1, and the image, oh no, that's not right. Object is found in quadrant 3. Roman numeral 3, sorry. And then the image is found in quadrant 2 or Roman numeral 2. Either one of these works. Letter D, a shape that is translated keeps the same, this is what we call orientation, which means it's not turned, it's not flipped. The actual letters stay in the same order. They're not turned around or in any way. So that means they keep the same orientation. So let's do these couple of examples here. You could pause the video just so that we can get the answers for this. So pause the video now, and I'll give the answers to you. The question is, if translation vectors or arrows of -3, 3 and 1, -2 are applied to triangle ABC, what are the coordinates for A double prime, B double prime, C double prime? And then I want you to draw ABC and the final image below. So let's start first just by looking at the coordinates. So the way that we solve this is we look at all 3 points completely separate. So we start with A, and A is 0, 4. Well, if I start with the first translation vector is -3, 3. And what we need to do is just add towards them together. So we start at 0. We go to the left -3. So, we go to the left 3. That means A prime will be at -3. And I'm at 0, 4. So let's just actually draw this then. 0, 4 is here. And I move to the left 3 and up 3. And it doesn't fit on this page, but we'll try it anyway. So we go to the left 3 and up 3. Well, it doesn't fall on the page. It doesn't fit on this page. So it ends up being at -3, 7. And then I apply the next vector, which is 1, -2. Oops. So that means if I move 1 to the right and 2 down, A double prime will be at -2, 5. So I do the same for all of them. So for the second vector, for the second point, I am moving -3, 3. So that means B prime will be at 5 plus -3 is 2, and 0 plus 3 is 3. How did I find that without actually graphing it? Well, what I did was I took the x-coordinate of the point, and I added the a value of the vector, and then ended up with the new x value, or the x prime value. Then I took the y value, which is 0. I added it to the b part of the vector, which is the second part of the vector, and I ended up getting the second number. So I see that x's and y's are completely different. I can move left and right separately from the up and down. So I can separate the two coordinates and do that separately. So then that means for this one, for my 1, -2, I'll add my x-coordinate to the a. So x-coordinate is the first number to the first part of the vector. So 2 plus 1 is 3. And then the second part of the vector, or the second part of the coordinate, so that's 3, plus the second part of the vector, which is -2. 3 plus -2 is 1. So 3, 1. If you're even more clever than that, what you might have realized is that you can combine both vectors together. So this vector of -3, 3 and 1, -2 is the same vector as the addition of both of these vectors. We call this the resultant vector. And so the resultant vector is -3 plus 1 is -2, and 3 plus -2 is 1. So this is what we call the resultant vector, because we added both vectors together. So this vector plus this vector, add them together, and this is the combined version of the two of them. So I can go directly to C double prime just by using the resultant vector. So -2 plus -2 is -4, and -4 plus 1 is -3. Let me just change this little thing so it doesn't look like a pie. There. So my 3 points are -2, 5, 3, 1, and -4, -3. So if I were to draw those on the graph, so I have 0, 4, I have 5, 0, and then I have -2, -4. So this is my original A, B, C. Whoa, that's not a very good line. Okay, and now I'm just going to change colors, and I'll draw my A prime, B prime, C prime. So -2, 5 is up here. 3, 1 is here, and -4, -3 is over here. Again, I don't know how to draw this line properly. But notice that both of these shapes are the same orientation. So I have A here, my A prime is there, B was here, B prime is over here, C and C prime. So it looks exactly the same, just slid over a little bit. And my vector, my resultant vector I saw is -2, 1. That means 2 to the left and 1 up. So all of these original points moved to the left 2 and up 1. So we have a couple of questions to do for homework at the bottom. We have this little example here, and we could try this one out in class so that at least it see if it's a little bit of a brain teaser, and then we'll try out the reflection and then the homework questions in class. So hopefully you understood this lesson,